Dear students, in this lecture, we are going to discuss about what is active power, what is reactive power, what is apparent power, how power triangle is obtained, and also calculate power factor. So, in this lecture, we are going to discuss about what is active power, reactive power, apparent power, and power factor, how power triangle is obtained. As we know that this is the impedance triangle, as we know that this is the impedance triangle. Impedance is the combination of resistance and reactance. Resistance is the real term, reactance is the imaginary term. So resistance is always taken as a reference vector, and reactance, J is always placed in front of reactance term, imaginary term, so that reactance is always perpendicular to resistance. So by combination of resistance, reactance will give the impedance. This is the impedance triangle. Resistance R cos theta. From the impedance triangle, cos theta equals to R cos pi equals to adjacent side by hypotenuse. Similarly, sin pi equals to R equals to Z cos pi. Similarly, sin phi equals to opposite side by adjacent side. Opposite side by hypotenuse. Sin pi equals to opposite side by hypotenuse. X by z. Sin phi equals to x by z. X equals to z sin pi. X is nothing but. So this is the impedance triangle. From the impedance triangle, magnitude z square equals to, as per Pythagoras formula, z square equals to hypotenuse square equals to side square plus side square. So z equals to square root of r square plus x square, and cos pi equals to r by z, r equals to z cos pi, and sin pi equals to x by z, x equals to z sin pi, and tan pi equals to opposite side by adjacent side, x by r. How power triangle is obtained means, if we multiply the three sides of impedance triangle by I square, if we multiply the three sides of impedance triangle by I square, then power triangle will be obtained. So I square into x, I am multiplying the three sides of impedance triangle by I square into x. Similarly, I square into x and I square into z. So if we multiply the three sides of impedance triangle by I square, power triangle will be obtained. So I square r can be taken as a real power. I square x can be taken as a reactive power, as we knew that. So I square into z is taken as apparent power or total power. Real power units are watts or kilowatts, and reactive power units are volt ampere reactive, and apparent power units are volt ampere only or kVA. So in this way, power triangle will be obtained. If we multiply the three sides of impedance triangle by I square, power triangle will be obtained. So I square R is taken as real power, this is reactive power, this is apparent power. I will define the real power definition. Real power is it is defined as product of applied voltage and active component of current. Active component means cos pi. Reactive component means sin pi. As we seen that R equals to Z cos pi, X equals to Z sin pi. So reactance contains sin pi. Sin pi is nothing but the reactive component. Cos pi contains the real component or active component. So real power can be defined as product of applied voltage and active component of current. How it is derived means, so as we know that P equals to I square into R. So I square R can be written as I into IR. I square can be written as I into IR, where R equals to Z cos pi. By substituting the I into Z cos pi. As we know that V equals to IZ. As we know that in AC circuits, V equals to IZ. So by taking the IZ is nothing but V into I into cos pi. So in this way, active power will be obtained. Active power is defined as product of applied voltage and active component of current. I square R can be written as I into IR. R equals to Z cos pi. So I into Z can be written as V remaining I cos pi. So VI cos pi. This is the active power, watts or kilowatts. Similarly, how reactive power can be defined means, reactive power is defined as product of applied voltage and reactive component of current and reactive component of Vi sin pi. How it is obtained means, as we know that reactive component, so I square into x, this is the I square into x. So I square into x can be written as I into ix, where x equals to z sin pi. So where x equals to, by substituting the x equals to z sin pi, z into I into z is taken as v, remaining term v into I cos pi. So q equals to vi sin pi, q equals to vi sin pi, reactive power. Similarly, apparent power, it is the product of applied voltage and current Vi only. It is also defined as apparent power or total power. S equals to, this is P, this is Q. Reactive power is denoted by Q, and apparent power is denoted by S. Capital P, capital Q, capital S. So S equals to P plus JQ, P plus JQ, or square root of P square plus Q square. So apparent power equals to Vi. How it can be defined means, product of applied voltage and current. S equals to, as we know that I square into Z. By multiplying the three sides of impedance triangle, power triangle is obtained. So I square into Z. I square into Z can be written as I into IZ. I into IZ. IZ is nothing but V into I. So in this way, apparent power formula we can also define in S equals to I square into Z or V into I. Similarly, reactive power equals to I square into X or Vi sin pi. Similarly, real power P equals to I square into R or Vi cos pi. Here we can see the power triangle. So this is the active power Vi cos pi. Just now I have defined reactive power Vi sin pi, I square into X, I square into R, I square into Z, Vi. So P equals to I square into R, real power inwards, Q equals to I square into X, reactive power, or Vi sin pi, and S is the I square into Z is nothing but Vi, apparent power. Similarly, phi is the phase angle, So cos pi equals to, from this impedance power triangle, cos pi equals to adjacent side by hypotenuse, P by S, and cos pi equals to P by S, and sin pi equals to opposite side by adjacent side, Q by S, and tan phi equals to opposite side by adjacent side, Q by P. So in this way we will calculate cos theta or cos pi, sin pi or tan pi. And power factor is also defined as the phase angle between voltage and current. The phase angle between voltage and current is nothing but power factor. From the impedance triangle, power factor can be defined as ratio of resistance to impedance. As we seen that from the impedance triangle, this is the R, this is the X, this is the Z. Cos pi equals to R by Z from the impedance triangle. From the power triangle, cos pi can be also defined as ratio of P by S. That means P is represented in kilowatts, S is represented in kVA, kW by kVA. So in this way, power factor can be calculated. The maximum value of power factor value lies in between 0 to 1 only. 0 to 1 only. So thank you.